Hello and welcome back to Calculus 2, section 7.5, partial fraction decomposition, part 2. Now we're going to solve more problems, take care of more cases. And we just need to remember again that if we have anything divided by the linear term, the setup is a over that linear term. If we have the repeated linear, it's a and b. And then unfactorable quadratic, we'll have linear ax plus b. And then repeated unfactorable quadratic, we'll have ax plus b and cx plus d. Also, last class we said that we can put as many of these as we want together. And I told you that for the exam, you are going to have one of these that it's either 2 or 3 variables to solve completely. And you're also going to have one which would be just the setup. So you write the setup for it, and that's it. So we focused last class on setup. And then we focused on solving some of the linear term problems. We did some factoring, but we only did, as I can see over here, 2 examples. So we'll continue with examples. So first, let's take a look at how we can work with what did we do? We did 14 and 30, right? 14 and 30. Yes, 14 and 30. These problems tend to be long and tricky. So how about 37? We start with, well, let's revise x squared minus 4 divided by x cubed minus 2x squared plus x dx. You might be responsible for factoring, which is okay because you learned that in algebra. Now we need to factor x cubed minus 2x squared plus x. We see that we can factor out x, which leaves us with x squared minus 2x plus 1. And if you paid attention, you see that this is x squared minus 1, x minus 1, everything squared. It's a square of binomial right there. So the problem is x squared minus 4 divided by x minus 1 squared dx. So the setup is a over x plus b over x minus 1 plus c over x minus 1 squared dx. So we have linear and then a repeated linear. Again, you must memorize those 4 setup cases so you can work this out. And now what we get? Well, first we do the partial fraction decomposition. So a over x plus b over x minus 1 plus c over x minus 1 squared needs to be equal to x squared minus 4 divided by the common denominator. And as I said before, we play the game of what's missing. So x minus 1 squared on the first, x times x minus 1 on the second, and x on the third. So you try to make each denominator equal to the denominator here. Now recall that this x squared, x minus 1 squared is this, well, not with the x, just this, without x in front. So you are multiplying a with all of those. So what do we have? We have ax squared minus 2ax plus a plus bx squared minus bx and plus cx is equal to x squared minus 4. Remember that all denominators cancel quickly because they're all the same. So now we pull a plus b together because those are the coefficients of x squared. Plus, then we pile up all x coefficients, which is minus 2ax, so minus 2a minus b plus c times x. And finally we have plus a. Nice. X squared plus 0x minus 4. 3 colors. So we have coefficient of a, coefficient of x squared, coefficient of x, and finally constant term. So a plus b is coefficient of x squared is 1. So the way this works is a plus b is the coefficient of x squared on the left side, and number 1 is the coefficient of x squared on the right side, and we equal those. And then you have negative 2a minus b plus c equals to 0, because the coefficient of x term on the right hand side is 0 when you do the placeholder thing. And finally we get, for free, a is negative 4. So if a is negative 4, well, you plug that into the top equation and you get that b is equal to 5 immediately. And now you feed both of these into the middle equation. So negative 2 times negative 4 minus 5 plus c equals 0. This is a positive 8 minus 5 is 3 plus c equals 0. And we get that c is 3. What happened? That's what I said, negative 3. Please pay attention. It clearly says negative 3. Do I need to zoom in? You good? Alright, perfect. So now we have a over x. So we have integral of negative 4 over x plus a b, which is 5, over x minus 1. And then plus negative 3 over x minus 1 squared, all of this dx. So we plug a for a, b for b, and c for c. And now we need to integrate. The only problematic term, somewhat, is this one. The rest are basics. We have negative 4 ln of x plus 5 ln absolute x minus 1, and then finally minus 3 times integral of dx over x minus 1 squared. What should I do here to solve the last one? U sub. Very good. U equals x minus 1. Du equals dx. When we substitute, we get negative 3 integral of du over u squared and here we go. So the integral of this would be negative 1 over u. But negative 1 and negative 3 makes a positive 3. And 1 over u, but u was x minus 1. So we can just call this 3 over x minus 1. And then plus c. Work this out on a napkin next time you go out. See what happens. A lot of cool situations. These are all textbook problems now. Problem 46. I'm changing from z's to x because it's easier to read. Let's see what you get. Set up, do the partial fraction decomposition, and then integrate each piece. Do we all have the same setup? The same setup? All right, great. So keep working on the partial fraction. Just wanted to check in real quick. Yeah. Do we all have the same stuff? A to be 1/4, B to be -1/4, and C to be 1. Are we all good with this? Perfect. Once we have our coefficients, we can write out 1/4 over x, right, because a is 1/4, plus, and now negative 1/4 x plus 1 divided by x squared plus 4 dx. This breaks into two integrals. The integral, well, we can kick 1/4 outside, so 1/4 integral of dx over x, and then we have another integral, and this one, well, let's write it one more time. So negative 1/4 x plus 1 over x squared plus 4 everything dx. Now the first integral is easy, just ln of x, and you're done. Now the next integral is a problem. And if you just pay attention a little bit, you see that that one can be broken into two integrals. And you can do that because you have addition in the numerator. If you studied 7.1, which was the review of basic integration from Calc 1, in that section there were few problems which were labeled as split the fraction. And that is the technique that I'm using here. So I'm splitting the fraction at this plus in the numerator. So I have the first fraction that it's negative 1/4 integral of x over x squared plus 4 dx. And then I have a second integral plus integral of 1 over x squared plus 4 dx. So these are the two integrals. So how do I solve the integral, the first integral? U sub, very good. U equals x squared plus 4, du equals 2x dx. I don't have the 2, so we'll put 2.5, and that will change some of the stuff around. And how about the second integral? It has a formula, it's basic, so which one is it?
1 over a squared plus u squared equals 1 over a arctan u over.
The inverse tangent. This is the reason why in Calculus 1 you had to memorize the derivative of inverse tangent. It's going to be frequent as the answer in partial fraction decomposition, and it's going to show up a lot later in differential equations as well. You need to know inverse tangent. So this one has the basic formula tangent inverse. That's all I'm going to write here. So 1/4 ln x minus 1 over 8 integral of du over u plus 1/2 inverse tangent of x over 2 plus c. I still have to integrate the one in the middle. So we copy 1/4 ln absolute x minus, and when I integrate I get another ln of x squared plus 4 plus 1/2 inverse tangent of x over 2 plus c. Welcome to partial fraction decomposition. Nice. Yes? Up just a little bit, sure. Any questions, concerns regarding this problem? We have 2 more problems and then we're done. Maybe 3, we'll see. All right, there are no questions. The next problem says, it's problem 58. You're going to love this stuff. The region is bounded by y equals 1 minus x squared to the negative 1/2 and y equals 4 is revolved around the x-axis. What is this? What are we looking for? Volume, yes. Find volume. So find volume. Now you have to figure out what method to use. You know 2. You know washer and shell. You have to figure out which one to use, set up, and apparently what you get should be partial fraction decomposition, right? Let's see what you get. Which method? Washer, good. Do we all have plus minus root 15 over 4 for limits? We also see it's negative and positive. Now we set the integral. Volume is equal to pi integral from negative root 15 over 4 to positive root 15 over 4. And then we have 4 squared minus 1 over square root of 1 minus x squared squared, and all of that dx. Questions, concerns? No questions, no concerns? Awesome. So negative root, oh, it's going to be annoying to write every time. So what do we have? We have 16 minus 1 over, and we can factor 1 minus x, 1 plus x. Dx. Now the square would kill the square root. Now when you're integrating this, you see that you need partial fraction decomposition for the second one, right? Now there's an issue with this one, which is 1 minus x. You need x minus 1. So 1 minus x is actually negative x minus 1. So you can kick negative outside. We have two integrals. The first integral is just 16 dx, easy. And now the second integral is plus pi integral of 1 over x minus 1, x plus 1. Dx. Because when you flip you have to observe that. So now integration is 16 pi x computed from negative root 15 over 4 to positive root 15 over 4. This negative? Because this negative and the negative from the, right, they combine. Plus pi integral, and now we have two linear terms, so a over x minus 1 plus b over x plus 1, and these guys will work out to be a half, right? Did anyone get it? I think these guys are half each. So a plus b is 0 and a minus b is 1. When you add these two equations immediately, you get 2a is 1, as I said, a half, and the negative half because they have to add to 0. So partial fraction decomposition is done. We have 16 pi root 15 over 4, minus and minus gives us plus root 15 over 4, plus the pi, and we have 1/2 1 over x minus 1 minus 1/2 of 1 over x plus 1. So this is 2. So we have 16 pi root 15 divided by 2 plus pi, and now integral inside, so this becomes 1/2 ln of x minus 1 minus 1/2 ln, I'll move the b, so 1/2 ln of absolute x plus 1. You don't put plus c because we have the limits. (16 pi root 15 over 2). Oh, 16 and 2 cancel to 8, so this is just 8. Plus pi. Now what I'm going to do is I'm going to combine this into a single log by division of these. So what we actually have is the square root of x minus 1 over x plus 1. Because when you factor out a half, these guys go, I mean there's ln in front. Let me write it nicely. I'm going to kick 1/2 outside, so pi over 2. And when I condense these guys, it's ln of x minus 1 over x plus 1. And we have our limits. So 8 pi root 15 is the copy, and now we get to plug in the values. So this is going to be ln of absolute value square root of 15 over 4 minus 1 divided by square root of 15 over 4 plus 1. That takes care of the upper limit, and now lower limit is negative pi over 2 ln, and now with the negative we have to be a little bit careful, so that's negative root 15 over 4 minus (1) divided by negative root 15 over 4 plus 1. All we need to do is to compute this and we're done. Easy. Or we can just call it done now. But if you multiply top and bottom by 4, you kill double fractions. And you just get stuff together with the argument. So the first one becomes root 15 minus 1 over root 15 plus 1. And the second one, again, after multiply by 4, we get negative root 15 minus 1 over negative root 15 plus 1. No plus c, because these are all numbers. You can take the calculator and calculate all of this stuff. Close the absolute value. So you are going to get some ridiculous decimals out of this. But such is life. in blood. If the degree of the numerator is greater or same as the one in the denominator. We must use polynomial long division before we apply partial fraction decomposition.
Should those minus ones be minus 4 since multiplying by 4, or?
Oh, yes. Good. Yes, yes, yes. All of these ones should be 4s. Good. Do what? All of these need to be 4s. Oh, I didn't finish yet, yeah. All right, so the degree of the numerator, if the degree of the numerator is greater or same as the 1 in the denominator, we must use polynomial long division before we apply partial fraction decomposition. And since I know how much you love examples, 66. Two x cubed plus x squared minus 6x plus 7 divided by x squared plus x minus 6 dx. Good luck. What do we have to do first? What do we have to do first? Long division. The degree in the numerator is 3. The degree in the denominator is 2. Therefore, we have to use long division. And partial fraction decomposition will only be applied to the remainder of that long division. What happened? Evil problem? Why? Because we have to use algebra? Uh-oh. So make sure you review this. I think one of the lab you also have these types of problems. So x squared into 2x cubed goes 2x times, right? Multiply back. Then subtract. Standard algorithm like for numbers. And this becomes negative x squared plus 6x plus 7, I think. Because subtract, yeah. And then negative 1. Multiply by negative 1, we get negative x squared, negative x, positive 6, and then we subtract. These are gone. Becomes 7x minus 1. So now you have So now you have your integral to be 2x minus 1 plus 7x minus 1 over, and if you factor this, you get x plus 3, x minus 2. And all of this dx. What you see is that the remainder is the partial fraction decomposition, and you know how to integrate 2x minus 1. That's basic. So partial fraction decomposition, a over x plus 3 plus b over x minus 2 needs to be 7x minus 1 over x plus 3, x minus 2. Multiply the first one by x minus 2 and multiply the second one x plus 3. And then just work out the equations. We have our two equations. Times 2 on the top equation and then add. Oh, this is so close. Should be plus 1? Ah, yes. We are adding. Should be plus 1. So that makes nice 15 over here. Thank you. So b is 3, and a must be negative 3 because, no. B is 3, a is 4. Much better. So what's our integral? Our integral is 2x minus 1 plus 4 over x plus 3 plus 3 over x minus 2. All basic integrals. Plus c at the end. Make sense? Good. Try more examples for homework at home. We are going to start a stream for numerical methods in 7.7.